Okay, today it's kind of a review day, and there's three main kinds of lines that you have to know. Standard form, which looks like this. I want you to write an example for yourself underneath it. Like, for instance, 3x plus 4y equals 7. That's where the x is first, and then the y is next, and then the constant is the last number. Okay, that's an example of a standard form. We don't use that much. We use it some. It's handy to know what a, b, and c are when you have a quadratic equation, but anyway. Actually, we don't even use it really for that. We use it more for elimination method. Anyway, this isn't used very much, happily. But sometimes your problems are given to you that way, and you got to solve them and make y equals, solve it for y, like this. You do that a lot. So your answer for this might be, let's say it came down to y equals negative 3/4 x plus 7 or something. That is a typical equation in slope-intercept form. And I hope you know that m is the slope. So the slope right here is this negative 3/4. And do you remember what the b is? Or in this case, a 7? The y-intercept. Very good. The y-intercept and the slope are found in that one. Hence, it's called slope-intercept. Does that make sense? Okay, we use that a lot, and I know you've already used where it's solved for y. You've done that a ton. This is the one that you haven't done as much, and yet we're going to use a lot. You're going to have to get good at this. Okay, and this is where there's a point buried in it, of course, and there's the slope in it. Which one's the slope? Bam. So here's a typical problem. Let's say I was going to use the point 5, 9. I would put in the 5 here and the 9 there. So it would be y minus 9 equals a slope. Let's say I pick a slope of 1/2 x minus 5. Do you get what I just did there? I put a point in there and there, and I stuck a slope in right there. And now I have this equation resulting. That's the equation for a line that goes through the point 5, 9 and has a slope of 1/2. What I find is usually there's like 3/4 of the kids have learned that before, and 1/4 of them that's totally new. Because it depends on which class you had last year, which teacher you had last year, whether you had it at the high school or at the middle school. There's a lot of options. So how many of you think you've learned that before? How many of you think you've never learned that before? All right. Okay. Well, if you haven't learned it before, it's going to, take you an extra few steps. I get it. But if you've learned it before, you should already be ready. I can give you a point, I can give you a slope, and you should be able to give me the answer. So I want to test you right now and see how many of you can do this. Here's a point. I'm going to give you the point 3, 7, and I'm going to have a slope of 1/5. I want you to write me the equation for that. If the point is 3, 7 and the slope is 1/5, write me an equation. It'll still have a y and an x in it, just like mine did. Your answer will look kind of like this, except you'll have your numbers and your slope in there. When you are done, I want you to zoom in on so it's almost full screen, and then turn and show me. It's one of the things I really couldn't do as a normal math teacher with paper, because I couldn't read it. Unless you write gigantor on your paper, it's just about impossible. And this I can check, and I can say yes, 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 yep, yep, doing it right. I'm waiting. Okay, good. Yes, 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 yes. Okay, good. And see, now I can tell from that many responses that I don't really need to worry about this one. So that's kind of good feedback for me. I'm not going to spend a ton of time on this because you already get this. So this next practice problem that we have, not much point to have you rewrite that thing in point slope form or whatever, because you already get that. How about just plain old graphing? Do you remember how to do that? Might have been a while. Let me remind you. So if I was going to graph this thing, it looks like, a line like this. That's not the exact right answer for this problem. That's just a little sketch there. But this problem, let's get rid of that, in fact. If I was going to graph it, I'd want it in slope-intercept form first. What that means is I basically need to solve for y. So everybody take this thing. Start by subtracting 3x from both sides. I'll need to do this one with you. And we're getting y alone. So now it's down to minus 4y equals negative 3x plus 8. Some of you are not writing, which means it's impossible for you to be doing what I asked. You can be done, that's cool. But do this problem with me. This is not just watch me do it. Next, I'm going to divide by negative 4 everywhere. Divide by negative 4, divide by negative 4, divide by negative 4. And this one cancels, so y is alone, just like I wanted. And this one's a negative divided by negative, which makes it positive 3/4 x. And then what does that make? Last hour I said it was positive 4. Oops. What is it? It's negative. What's 8 divided by 4? Negative 2. All right. So now, what's better about that? I can tell the what from it? The slope. I know what the slope is. And then do you remember what this part right here is called? The y-intercept. So if I were going to graph it, I'd start at negative 2 on the y-intercept. It would be like down there. And then from here, I would have a slope of 3/4. Do you remember that the top is the rise and the bottom is the run? So rise 3, run 4, and it would look something like that. Would be my final graphed answer. It didn't ask you to in this problem. All it did is ask you to change the slope-intercept form, but that's why you do it, is because now this is so much easier to graph. All right, this one, solve it for y. Turn it my way. I'll tell you if you did it right. Make sure that it's in the right form. Like, you don't want to have the x part be last. You want the x part to be right after the equal sign. Wow, it's really squeaky. All right, simplify that 4/2 part. You lost a negative. Yes, you lost an x. Yes, yes. You wrote it backwards. You just want the y in front, that's all. Yes, you lost a negative. Yes, 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 yes. Oh, wait a minute. Yeah, that one's right. And that one's... I'll say yes, that one was right. You're good. Okay, good, good, good. Okay. Thank you. You got to throw an x in after the 5 and you'll be good. All right. Maybe you have it there and I just couldn't see it. So in this one, I should be solving for y. I'm subtracting 4x. It'll be 2y equals minus 4x minus 4x. Negative 4x plus 10 divided by 2. Y equals negative 4 divided by 2 is negative 2x. And then this 10 divided by 2 is 5. There we go. And why is this good? Because I have the slope and I have the y-intercept. So if I ask you to graph it, which is the next part, it'll be easier. All right, get to this page. This is a common thing kids get goofed up on, is graphing when it's just a y. Well, find a spot where y is negative 3 and put a dot there. On the graph, find where y is negative 3 and put a dot. Just one dot. All right, so it should have popped in right there. Now, the only question is it a vertical or a horizontal line? If you think about it, it can't be a line like this because that would include all these spots where y is not negative 3. It can't be a line that goes like that. It has to go the other way. That's the way I like to think of it anyway. Instead of trying to memorize that y's row is horizontal, there's too many things out there to try to memorize to keep those straight. So just graph one point and then think about it. Here, would you agree that that's x equals 5 once I divide by 2 on both sides? So if I'm going to say x equals 5, I'm going to find the spot where x is 5. There's a spot where x is... Oh, is that 6? Yeah, that's 6 actually. I'll move it over. There we go. And now, think about it. Up and down or left and right? Vertical or horizontal? Vertical. It's a vertical line going like that. All right, so if they're just one letter, that's how you graph them. And what if it's like this? I'll give you a hint. This is slope-intercept, except there's no intercept. Wouldn't it be nice if it was like a 5 there? I'd know I should start at 5. What number is there right there then, really? There's a 0 there. So you start at 0. And now, that's the y-intercept. What's the slope? The rise over the run. What's the rise? Rise is 1. Some of you are no longer with me. Come back. You're working on this problem right here in your notes. All right. And the rise is 1 and the run is 2. So I'm going to, from that dot, at 0, 0, you're going to rise 1. You're going to run 2. And then turn your graph my way and let me see if you did it right. Good, good, good. Now some people are using all dots, good. Some people are using lines. Both are good, but technically just know there's supposed to be a bunch of dots that have a line connecting them. There's only one dot, so it's hard to know. Good, 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 good. Never saw yours. Oh, your iPad doesn't work. That's right. Good, 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 good. Okay, people are doing it right. Not too worried about this then. This one, what's the first step? You'd solve for y, and then you'd graph it. It's pretty easy. I'm not going to make you waste your time on that. Let's move on. How about these inequalities? How are they different? The only thing different is that you want to shade above the line or below the line when you're all done. That's the main difference. There's one other thing. This one, think of this as like an equal sign, and you just act like it's an equal sign until the end. But then when you graph it, one of these two, the one I circled in black or the one I circled in red, one of those two gets a solid line and one of them gets a dotted line. Do you remember? Is it the red one or the black one that gets the solid line? The one I circled in red or the one I circled in black? Interesting. I'm getting a division in the class. I'll just solve it for you quickly here. Which of the two things that I circled has a solid line in it? That's the one that has a solid line on the graph. This one gets a solid line. Because the things that are on the line will work because they will equal the other side. So if you actually put in a point that's on the line, it'll work. Whereas this one, if you actually put in a point that's on the line, it won't work because it'll be a point like 3 is less than 3 is what it'll come down to, and that's not true. So anyway, the point is one of these two has a solid, one has a dotted. This kind has a solid line in it. This kind has a solid, so LID line. And this one has a dashed line. Okay? All right, so now let's actually do this first one. So if I were going to do this, the first step I would do is probably recognize, oh, do you recognize that? That's point slope. Do you get that there's a point right here? And the slope is 3? Maybe you noticed that, maybe you didn't. Maybe some of you thought, well, I'm just going to multiply this whole thing out, and that would have worked. Okay, you could multiply it all out and you get slope-intercept form. Either way will work, but the fact that this is in point slope is like not just a coincidence. So what is the point? Now be careful here. Is it 4 comma 2 or negative 4 comma 2 or 4 comma negative 2 or what is it? Well, would you agree that the x is the 4? And then the only question is it a positive or a negative 4? It's a negative 4. Because the standard form of the equation has a negative right there, and this one has a positive, so it's opposite from normal. All right. Then this 2 here is clearly the y. Now, is it a 2 or is it a negative 2? If there's a negative in here, it's the standard form of it. It's the normal way to do it, so it's a normal positive 2. Okay, so you got to go back to the original. Y minus y1 equals m times x minus x1. Notice that it has minuses in it if it's the normal form of the equation. This is not a minus, so it's the opposite of normal, and therefore use the opposite sign. So the point is negative 4 comma 2. Where is that? Negative 4 comma 2. Put a dot there on your graph. And from there, what is the slope? Come on, where's the slope in there? 2 or 3 or the 4? It's the 3. That's the slope right there. That's the m. So it has a slope of 3. That means from there, I rise 3 and I run 1. And I rise 3 and I run 1. Get the idea? All right. So I started with my point, and I had to be careful with negatives. And then I just did my slope of 3, which made my final answer look like that, except technically I should connect them with a solid line with arrows on both ends. Okay? Question, did I screw something up?
Yes.
I believe you. Ah, there we go. You're right. I did a solid line through there, which is an okay way to start, but then you'd have to go back and get the eraser out, like I'm going to. I'm going to use my surgical eraser, tiny little eraser, and just put in a few little dashes in my line. There we go. You're right. It needs to be a dashed line because it had a less than sign. It wasn't an equal to sign. Does this one have an equal to sign in it? Then it'll have a solid line. Okay? So when we graph this one, it's going to have a solid line. First step, minus 2x, minus 2x. Then it's negative y, and this is important. Negative y is greater than or equal to negative 2x plus 10. I haven't done anything wrong yet. But right here, when I divide by that negative to get this y alone, I'm going to divide by negative 1. Divide by negative 1. Divide by negative 1. I could have multiplied by negative 1 just fine either way. But the sign needs to switch now. Do you remember that? The sign switches whenever you divide by a negative or multiply by a negative. That's the only time the sign will ever switch, is if you multiply by a negative or divide by a negative. Now, if you're taking notes, which you are, if you're writing on your iPad, this is one of those, remember to switch sign if divide by negative. However you want to write it, that's the important part. That's like really important part. Out of this whole slideshow, that's the most commonly screwed up thing. I'll try to point out those really important things to you, but you'll never remember it unless you actually put a star by it or something. So I recommend you have a symbol for yourself. I don't care if it's a star, a smiley face, a sun shape, whatever it is, I recommend you mark it in your notes. Why? I want you to have excellent notes so that if you want to be the ultimate student, you can be. You don't want to hinder yourself later because you didn't take good notes. Taking the notes themselves help you learn. But if you really want to be the ultimate student, I only know one person in my entire life that I actually knew who got all A's in every high school class and every college class. They never got less than a straight A. And it wasn't because they were a genius. They were not a genius. They were really good about reviewing what they had learned each day. Memory research says that if you don't review something within 5 hours of when you first learned it, that you will probably lose almost all of it. But if you review it within 5 hours of first learning it, you will keep it for a long time. Not forever, but you keep it for a much longer time. And if you can review it once more before you take the test, you probably remember everything I ever teach you. If you can review it once within 5 hours and another time before the test, you'll probably get every single problem right, other than making a dumb mistake like now and then like I do, and you saw me do. Dumb mistakes don't count. That doesn't mean you don't know how. Yes, sir?
The problem be greater than, will you have to shade in the proper side of the line as well?
You are correct. We had not shaded that line yet. So let me come back to that in a second. I'm going to shade both of them at the same time. I'll show you the difference between them. All right, so on this last one here, I was down to I had switched the sign. One of the things that kids most often forget to do. 2x, and then this makes minus 10. How many of you had that correct equation? 2x minus 10. Okay, good. Now, if I actually graph that, am I going to use a solid line or dotted line? Solid line. And I'm going to go through the point what? What's the key point here on this one? It's the y-intercept. The y-intercept is what? Y-intercept is negative 10. So I'm going to start at negative 10, and I have a slope of 2. So that's rise 2 and run 1. It's almost like there's an over 1 here. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. There we go. And now I use a solid line. That's the difference. And now let's go back and shade both of them. I really should have shaded the other one before, but now I'm going to get to both of them. Which way do I shade them? It comes down to if it's solved through y. This is important. You can't have the y be like have stuff next to the y. But if the y is solved like this, then I can trust as long as that y is not negative. Because see, if I had a negative y there, the sign would be opposite. If that y does not have a negative on it, then I can trust that if it's a less than sign, I shade below it. If it's a greater than sign, nope, that's a less than sign also. They're both less than signs. So I shade below things that are a less than sign and shade above things that are a greater than sign. Most of the time in life, math makes sense, and less than sounds like underneath, doesn't it? I hope less than sounds like underneath to you. So we shade underneath this graph, and we shade underneath this graph. They both came out to less than signs. If they had been a greater than sign, of course, I would have shaded above it. All right, what does it really mean? It really means if I pick any point, like let's say 0, 0, if I stick it into this equation, the things that are above this line won't work. Like 0, 0 will not work. Put in a 0 is not less than negative 10. That's what I'd get. 0 is not less than negative 10. All right, so it's just saying that all the points that are underneath the graph here will work, and anything above it, like that point, 0, 0, or anything else that's above the line, won't work. Okay, moving on. This is just a big, hairy, nasty equation. And it doesn't take any particular intelligence to solve it, but it's just try not to make dumb mistakes. There's a multiplication in it that some of you will goof up. When it's all said and done, your answer will come out to a decimal like 2.5. It's not the right answer, but it'll be like that. See if you can do it without me. This is just plain algebra. Now, as you're doing it, I want to remind you to show your work. Show your steps. In calculus, when you take calc someday, many of you will take AP Calc. There's this big thing called the AP Calc test. And if you do well enough on it, you can get college credit for it. My kids did well enough on those when they went through high school. I guess still got one in high school, but I got 2 that are through. That they got a lot of college credits for that, which means that basically saved me about half of a year of college, which realistically saves me like $10,000 or $20,000 as a parent because my kid got a bunch of college credits in high school. So anyway, if you end up in AP Calc, or the other version of IB that's like it, there's an opportunity to take this big test. In AP Calc I can speak for, I'm not sure about the IB, but I know it's similar. But in AP Calc, every problem is worth 7 points. The answer is worth 1 point. The other 6 points are for the work. I know some of you don't like that because you're like, I can get the answer, but I hate showing my work. Deal with it. Get used to it. If you don't show work, you're not going to get the credit. In the AP test, seriously, if all you have is the answer, you get 1 point out of 7. You could be a genius and write down the answers without work and get 1 out of 7 and fail the AP test. You have to show work. So get used to showing work. All right, if you think you have it, would you turn it my way and I'll tell you if you did it right. Nice. Yep. Close, but no. You made a common mistake. Nope, you're close. You're right, except you haven't finished. You have to get a decimal. Do one last division. Nope, you're off a little bit. Made a common mistake. You've got it. Nice job. You've got it. You've got it. Nope, you made the common mistake. See if you can find your mistake. Yes, nice job. Nope, you made one little mistake. I think I know which one you made. Something's wrong with the negative. Other than that, I think you have it. Something's wrong. All right. So for those of you, about half of you got it right. I'm going to show you what the right way to do it is. If you have this line, I bet you, if you made a mistake, I bet you made it right here. 6x plus 30. So far, pretty much everybody will be right. Negative 15x. Now be careful right here. That makes positive 10. That's a really common goof up. How many of you caught yourself right there? All right, thank you. Many of you made that little mistake. It's just really easy mistake to make. Now I'm going to put together this and this. And that makes negative 9x, another common place to make a mistake, plus 40, putting these guys together, equals x plus 5. And now I have x's on both sides. I have to get rid of one of them to be able to solve it. You can always get rid of the smaller one. Smaller one's the negative one. So I'm going to get rid of this negative 9x by adding 9x to both sides. And then I have 40 equals 10x plus 5. I'm almost done. I'm going to subtract 5 from both sides. Now I got 35 equals 10x. Now I divide by 10, 3.5. 35 divided by 10 is 3.5. If you know where you made your mistake, that's all that really matters. It's not that big of a deal if you get one wrong here or there. It's learning from it. Like, if you get one wrong in your homework because you check it, it's learning from it. It's like, oh, here's my answer. Here's what I did. What did I do wrong? Don't just copy down that the answer is 3.2 or 3.5 in this case. Take the second to figure out where you made your mistake. All right. And that's all I have for you. I don't think we need to do any more extra practice than that because you were fine on that. So I'm not going to give you a little mini test either. I'm just going to jump you right into your homework. Now your homework is in that Schoology. So those of you that don't have your assignment with you, I'll at least put it up on the board so you can do the first few off the board. But if you don't have your iPad, that is going to make this class go a lot slower. So I encourage you to get it and get it working as soon as you can. So let me see if I can find my, pause for a second.